Hello, I'm Mark Licht. I'm an associate professor and extension cropping system specialist with the Department of Agronomy. Today, I'm going to spend a little bit of time talking about soybean management practices and how we can basically exploit some of those practices to make sure that we're attaining higher soybean yields. So, when we think about grain yield, there's a number of different factors that come into play, and I've kind of just put them into four big buckets here. We got weather, soil, cultivar genetics, and then management. For the most part, weather we really don't get to dictate, right? So radiation, temperature, rainfall, it's what's basically given to us. Maybe an exception to that would be the irrigation that I have kind of listed over there underneath the management side. That's the only attempt that we have to kind of manipulate the weather factors. On the soil factors, again, for the most part, this is what's given to us. Organic matter and soil texture, cation exchange capacity, microbial activity, hydrology. They're kind of just what's there in the soil for us. Now, we can maybe manipulate that a little bit depending on what we're using for residue management, what we're maybe using as far as our fertility. If we're using manures, we are going to pull in some more organic matter. We're going to increase that cation exchange capacity slightly. And then maybe even if we've done enough of those, then that really starts to cycle back with our microbial activity and the hydrology portion of it. Now, cultivar, I kind of pull separate from management because in some respects, we have the genetics that, companies are providing to us. We can use these cultivars from a risk management perspective, whether we're looking at the crop maturity, whether we're looking at the type of traits, for insects and diseases that that they're offering as far as susceptibility or resistance to those things. And then there's some, I'll call them plant architecture things that come out with physiology and morphology that we might be able to choose a little bit from. With soybeans, the first thing we think about there is, an upright versus a bushy type of variety. But where we can really influence grain yield is really in those management practices, right? And I'm going to spend most of the time in this presentation with planting date, seeding rate, and row spacing. There's other colleagues that probably can do a much better job with fertilization and pest management than I can. And then with irrigation, we just don't have very much of it here in the state of Iowa. There are times in the last couple of years might illustrate that, there's times when we do have some dry periods and irrigation would be beneficial. But by and large, we don't see the year in, year out benefits from that irrigation. So when we think about all these factors, I think it's also important to recognize, both with corn and soybeans, that these factors, I've simplified it here in saying that they're additive, but quite honestly, they can be multiplicative. And then there's also this whole idea of they're each interacting with each other a little bit differently. And I'll try to point that out with planting date, seeding rate, and row spacing as I go through this. As we get going in, just wanting to highlight and point out, kind of where some of our high yield potential is right now. This was actually published in 2015 by Ryan Van Rokel, and as you can see, it's still got those high yield numbers in it. There's maybe a few newer ones that can be added to this, but the highest one here is 137 bushels per acre out of China. South America has a couple up there in Argentina that are really high, over 100 bushels per acre. And then as far as into the U.S., we have the Southern Missouri, and then we have one by Wooster, Ohio, that are just over 100 bushels per acre. When I look at all of these and kind of think of common threads with this, the first thing that I kind of key in on is the maturity group column, and you can see that for the most part, these are maturity group 3 or later. So basically, needing to have enough growing season to be able to pull high grain fill capacities out of it. And then the next part that I look at is over there in that management comments and that column there. Because when you look through that, one of the things that you'll notice very, very quickly is almost all of these have some sort of irrigation with them. The one that doesn't is actually a converted rice paddy that's rain fed. So just tells you it's a little bit of a wetter environment. Another common thread here is that they all have either manure or they're supplementing back in with nitrogen, phosphorus, and potassium at a relatively high level. They all are all except for one, I believe, are using narrow rows, and so either 15-inch rows or a drilled type spacing, and they're all planted very, very timely. For the most part, they're going to be on the early side of the adapted planting range for the given area. So if we look at all those, that gives us some insights into some of the things that we should be paying attention to. Like I said, I'm not going to talk about fertilization or irrigation, but if we're looking at increasing our yields, we need to make sure that we have the fertility out there in the fields. Rainfall again is going to be a key indicator on if we're going to be able to attain high yields or not. But then row spacing and planting date do come into play, and we can find some nice synergies with those as we think about our own management here in Iowa. Another slide that I've pulled out of the archives. This slide is actually from Ceterius orchentulus, and a couple years ago, he ran a scenario looking at 37 weather years and just simulating for common recommended practices, kind of what the yield potential was in Iowa, and it was about 66 bushels per acre. There in the yellow area, what he did is he just increased those things by a single factor. So in the one simulation, he just increased the soil organic carbon. The next one, he just increased the nitrogen, increased the water, increased the root growth rate. And one thing that just notice that by just increasing those single factors, none of them really had an impact on our soybean yield or the estimated soybean yield. Over in the greenish bluish area, you can see some factors that did start to change what our yield potential was. The first one there was more radiation. Basically, he removed the cloudy, rainy days and replaced them with a sunny day. So not something that we can do, but it goes to show that with soybeans, if we can get more radiation to that plant, it's really going to help us improve our yield potential. Now I'm going to skip over to the radiation use efficiency and increasing that because that's another way of doing it, basically saying, well, we can't change how much sunlight we get, but if we can produce a crop canopy that is increasing the overall radiation use efficiency, how much basically biomass or grain yield we get per unit of radiation, then all of a sudden we can start to see those yields. And so for the focus of this presentation, I'm really thinking about that in terms of planting date, row spacing, and seeding rate. And so are there some things that we can do there that increase our canopy radiation use efficiency so we can intercept more radiation to kind of get that benefit from having higher radiation there? Okay, so there are some things that we can do to help us improve that aspect of it. Okay, so again, I'm going to focus mainly on the row spacing, planting dates, and plant population. The one thing here that I'll say from the standpoint of variety selection is that we have to make sure that we're selecting varieties that are very robust and high yielding at that. And so what are we talking about there? It's really making sure that we have soybean varieties that basically stand the test of time. They can be tested out in high yielding across multiple locations and across a couple years at very least. And by doing that, what we know is then we're getting those varieties that can hold up under different management conditions, different environmental conditions, and then therefore we kind of are capturing and minimizing some risk that's associated with those. So just jumping in and starting to think about narrow rows. This is a survey of farmers from across the U.S., and so just showing you the kind of the geographic spread there on the left-hand side. But as we think about the response to row spacings and these farmer responses, about 30% of the time there is less than a 1 bushel response. And in some of those cases, it was a negative response. About 40% of the time there was a response in that 1 to 4 bushel area. And then once we got above 4 bushels, there was almost another 30%. Okay. So what we really can find here is that yes, there are situations where we can get a nice yield response to narrowing that row spacing. So going with 15-inch rows or going with drilled soybeans. And then there's some times where we may or may not be seeing a response, and that response just may not be as large as we had wanted to. So that's from some farmer responses and some farmer surveys. This is some data that was compiled by Corteva, and I did include the citations there to kind of give you some year context, but then also illustrating some of the areas where this data was collected from. And so from this data set or this group of data, what we see is that the drilled versus 15, so again, both considered narrow rows, there were 6 studies and really no yield difference. However, there in the center and the right-hand side, the drilled and the 15-inch versus 30, both of those had a positive yield response, right? And so when we sit back and we think about what's going on here, it does come down to is we're trying to close that canopy quicker, and by closing that canopy quicker, we're intercepting more of that sunlight. Okay, so thinking about this and where we're getting these responses and where we aren't is another point to consider, right? So if we think back a slide to the farmer survey, there is clearly some sites where farmers were not seeing a response to narrow rows, right? And so this is partly an interaction with planting date. We know that if we're planting on the early side of things, or even within the well-adapted time frame for timely planting, the chance for narrow rows to have a positive response is decreased a little bit, right? And so partly what's happening here is we're looking to get our canopy closure, quite frankly, before we get to pod set stage. And so early planting, so before the 20th of April, narrow rows are likely not going to show us much of a response. Within that well-adapted time frame, so I'll say April 20th to May 10th, give or take, narrow rows in some years may have a response and in other years may not. Whereas if we are planting after after May 20th, the response to narrow rows is a lot more predictable, and we're going to see a lot higher response from it. So there is an interaction going on with planting date and row spacing, and so if we pay attention to that, if we do get pushed into later planting situations, if we can find ways, think creatively about how to get narrower rows, we can take advantage of row spacing to help us maintain yield potential there. So there are some caveats that come along with narrower row spacing. So the first being wheel tracks, typically related to herbicide applications, sometimes with fungicide and insecticide applications. We can see anywhere from a 1 to a 5% yield penalty because of this wheel traffic, and that range largely is attributed with the width of that sprayer boom. So the shorter the sprayer boom, the higher the yield penalty we'll see. Disease susceptibility is also another concern when we get into narrow rows because we're really clamping down on that canopy. We're minimizing airflow through that canopy. And so diseases like white mold can be more problematic. And so we just have to pay attention to that. The rotational complexity aspect. A lot of farms in the state of Iowa have just a single planter. And so being able to justify a narrower row, a 15 or even a 20-inch planter for both corn and soybeans is, it's something that we need to be making sure that we can balance, right? There's a capital expense to changing out our planter, even the corn head spacing, wheel spacing, and wheel size. And so we do have to pay attention to that. However, if we do have farms that are large enough where they do have multiple planters, I think this is where we can get some definite benefits from having a narrow row planter dedicated for soybean planting. So planting date, quite honestly, planting date's just as important for soybeans as it is for corn. We don't really want to put soybean seeds in the ground when it's too wet and too cold. it just leads to seedlings with disease or seeds that end up dying on us. But we do know that we can plant soybeans maybe a little bit cooler than maybe we were thinking, 20, 25 years ago. So 50 degrees soil temperatures and rising is still pretty good. That works for both corn and soybeans. And then just looking at making sure we have a nice forecast to let them imbibe water and get germinated, get the radical root off and going very strongly, right? So these planting conditions really hold true for both corn and soybeans, and I think if we pay attention to them, we can optimize what's going on right around the time of planting. Now, thinking of planting date in and of itself, I'm reaching back to the farmer survey where they gave us field yields and when they planted, and our colleagues out of Nebraska, they did this analysis, and they like to do called a boundary front. And so what it's showing is kind of the upper boundary of planting dates and what that response looks like. So each of the different colors there does align with some climates and soils that we do have in Iowa. That's what the colors and the maps are referring to. And so one of the things that we see here is that for the most part, farmers in Iowa, they're really not planting much before the 25th of April. But as you can see, as you get later and later, that yield potential does decline, and that happens statewide. The amount of yield penalty per day varies from region to region, and it's partly just a factor of the years that we were collecting this data and the weather conditions in those years. But somewhere in the idea or the range of zero point 0.2 bushels per acre per year up to even like a half bushel per acre per day is what that yield penalty is going to be associated with. So looking at, again, just some of the research data that was collected, and what we see with this planting date response is that on May 20th, that's kind of the breaking point. Before May 20th, there's really not any yield penalties. So if we can get in there and get them planted and have everything planted before May 20th, we have our highest yield potential. Notice that after May 20th, we start to see that variance around that regression line increase. And this almost always associated with weather conditions. If we get good weather conditions with a couple nice rains in August, that yield penalty is going to be less severe than if July and August are drier and we've used up all that soil moisture. So there are some things that are going on with the weather that affect what our yield potential ends up being as we get into those later planting situations. One thing I do want to note is that our modern soybean varieties, they are flowering about 1 week earlier, and they're holding on in the fall a little bit longer as well. And so we're getting about 14 more days of grain filling. And again, I think this is important because it's partly why we have good yield potentials out until May 20th, but it also goes to show that genetically we're trying to capture as much of the growing season as we can, and we're trying to convert as much of the growing season into grain fill as we can. And so part of it's a genetic thing, but part of it is us being able to take advantage of that through the variety maturities and through the planting dates that we end up using. So with early planting of soybeans, what we're really looking at is trying to increase that seasonal capacity. If we're in that timely range, we're going to increase our main stem nodes and we're going to increase our pod set, predominantly because of a higher growth rate. And then ultimately we end up with a longer reproductive period and a greater seed filling period. So those are all really good things that that we can take advantage of. Now, there is the concept of maybe planting a little bit too early or ultra early planting. And so then in those situations, maybe we're not going to get as many of those benefits as we would of just planting on the early side of the timely planting range. So this figure here, just to kind of set it up, is showing the plant density for soybeans that were planted in mid-March um, in 2017 and 2018, and they were a 3.6 and a 3.9 maturity group. So those are the greenish colored bars. And then on mid-April timeframe, I think it was April 14th 1 year and April 17th another year. But again, the 3.6 and the 3.9 maturity groups, and that's that blue and red bars. So one of the things that you notice here real quickly is that that 30 days earlier of planting really did kind of penalize the plant density. We lost about 20,000, give or take 20,000 plants per acre. One thing that I couldn't put on a bar graph, but one of the things that you notice um, in this as an artifact, within this is that the mid-March emerged roughly 5 to 7 days before that mid-April planting. And so that seed sitting in the ground 3 weeks longer kind of penalized it, and we had some seed death and some seedling disease that impacted us. Fortunately, even the mid-March, we had roughly that 100,000 final stand that we really hope for. And so when we look at the yield potential from this early planting versus the later planting, there's really no statistical difference in 2017 or 18. So while numerically the 3.9 maturity group in mid-March looks a little bit higher, statistically it was no different. So we can plant a little bit too early, and one of the things that is going to penalize us there is just we're going to have a lower emergence rate, a little bit higher seedling disease potentially happening there. Out in Purdue, they did a little bit of work around this, and so the height of the bars here is showing you the emergence rate, and then the black number at the bottom of the bars is indicating the number of days that it took from planting to emergence. And so one of the things that you can see is that those the March 30th and the April 13th, again on the earlier side for this location in Indiana, they had a lower emergence rate and they sat in the ground a little bit longer than kind of the ideal time frame being April 27th to May 10th. And then that May 30 to June 6th timeframe, you see that emergence rate does drop off a little bit. And part of that's just because it was a little bit drier spring conditions. But again, note that they did germinate and emerge relatively quickly. So the other part of this is when we plant that early, what happens? And so again, looking at that same study, the ultra early versus kind of the normal planting time frame, the number of nodes per plant really did not change. So again, the seed sat in the ground and maybe emerged 7 days ahead. So it really didn't have that much additional advantage with capturing radiation, putting out more leaves and nodes and things. Notice that with late planting, we do knock back the number of nodes pretty severely with both the May 30th and the June 6th. What's happening here is largely that we're shortening the vegetative growth period, kind of speeding that up and getting it into reproductive phases as quickly as the plant can. And so because of that, what we impact is just the number of nodes that we have. The other part of this is looking at the pod numbers per plant. And again, the early versus the normal pod numbers are the same. We start to see those back off a little bit with May 30th planting and then drop off fairly significantly with the June 6th date. And again, attributed with we're shortening the vegetative period, trying to get into the grain filling period as quickly as we can. Switching gears a little bit and jumping into plant populations, I thought I'd just start this one just showing the plasticity, in a plant to respond, just so to speak, to the number of neighbors that it has. So on the far left side there, what you're seeing are plants that were taken out of a 275,000 seeds per acre treatment. And then the middle one, the big bushy plant, that was taken out of a plot that had 25,000 seeds per acre. And so you can see very clearly there that, the higher seeding rates, we have maybe two, three, uh, at max four branches per plant there. Whereas when you look at the much larger, bushier plants, it put out a lot more branches, and you can see on those branches that there are pods, both at the higher part and the lower part of those branches, and so a lot of plasticity within the soybean plant to respond to that seeding rate or that plant population. At the same point, I'm showing an aerial image there on the right side that's just looking at how much ground cover just ahead of soybean flowering, and so the top left is 25,000 seeds per acre. B is 125,000 seeds per acre. C is 225,000, and D is 275,000 plants per acre. And what you can notice there is just looking at how much canopy cover we have. And again, I think the key thing here is that we do want to have full canopy cover by the time we get to pod set. So in this, looking at these four, it's very likely with another 3 weeks of growth that the upper right one that was seeded at 125,000, it'll be really, really close to being at canopy cover by the time we get to pod set. So I'm illustrating, some of this plasticity yet, but also trying to convey what's happening in this data set here. This is an older data set. It's one that Pella Peterson had put together a number of years ago. And it shows pretty clearly that in that 125,000 to 140,000 range for seeding rate, if you look over and move that over into the final plant population, it gets you pretty close to 100,000 plants per acre, which from an economically optimal standpoint is our economically optimal yield, just under that 100%. Okay, so it's taking into account the cost of the seeds to make that work, right? So you can kind of see what that response looks like there. But I think the thing that I really wanted to highlight here was plant mortality. And so these are final plant populations there in that center column. And when I factor or calculate in what our plant mortality was, you can see that those high seeding rates were above 30% mortality. We get down to 125,000, and now we're only at 25% mortality. And our mortality continues to drop as we go lower with those seeding rates. So, with this, I guess it does take a little bit of a balancing act. We have to kind of juggle where we need it to be. But I think it does show that once we start planting upwards of 175,000, 200,000, we have a lot of mortality happening between the time of planting in emergence and clear out until we reach our maturity stage there. So just thinking, a little bit about variable rate seeding and how this is all factoring in. We know that soybeans can compensate really well for reduced stands. There's even a response rate with planting date. Another thing as we think about variable rate seeding is we know that lower seeding rates have a lower bottom pod cluster. And this may seem, somewhat trivial, but if we lower that bottom pod cluster, it may or may not be harvestable, or the sickle bar may start cutting those pods and shattering out beans. So when we think about variable rate seeding principles and what that really means as we move forward with seeding, we can kind of group things together, I'll say. So we know that higher yielding zones, higher yielding fields or within field areas, we can drop the seeding rates because those areas are able to maintain yield potential at a lower seeding rate. As I alluded to earlier, if we have areas that are susceptible to white mold, we may want to decrease that seeding rate, kind of open up the canopy a little bit, get a little bit more airflow in there, so that way we can maybe help with that white mold susceptibility a little bit. Increasing the seeding rate, poor seedbed conditions, so this may be compacted areas. If we have maybe situations where we might be expecting soybean crusting, Weather conditions, that are maybe not ideal. So cold and wet are the main ones that I'm concerned with there. And then insect and seedling disease issues. So as we think about insect and seedling diseases, obviously if we have increased pressure, so it might be from cover crops, it might be something like iron deficiency chlorosis or soybean cyst nematodes, right? Where we're either expecting to lose more plant stand or whether we have more stunted plants. The idea is to increase that seeding rate a little bit to help offset that. Now, the issue is how much do you increase the seeding rate in these areas, because they're probably not going to be the highest yielding or the most productive areas of the field either. So the thought process is maybe try to increase the seeding rate by roughly 10% to kind of compensate a little bit, see if you can gain a little bit and help manage weeds a little more just from getting a better canopy closure. So after growing the plant, we have to think about protecting the yield. And so here, that tan bar kind of just shows you the leaf area index of the plant as we go from basically emergence out to the pod set time frame. And as you can see, the green bar is the crop growth rate, and they follow each other, right? So as we get more leaf area index, we're increasing that crop growth rate. This is really important because when we get into pod set, we're really transitioning the plant from vegetative production to grain filling. And the higher we can have the crop growth rate when we go into grain fill, the higher the grain fill potential we have. And so once we get this plant established, this factory established, we need to protect it. And so when we think about protecting the plant, what we really are doing is we're using things like the GMO traits to help us control weeds a little bit more easily. So that way we have less competition there. We're thinking about things like foliar fertilizers, not foliar fertilizers per se, unless we know we have a known deficiency, but foliar fungicides and foliar insecticides. If we have things that are out there defoliating the canopy, if we have a lot of foliar diseases out there, insecticides and fungicides can help us protect that and help us carry that plant through maturity. So this is just kind of a look real quick at how transgenic traits might be helping us. This is just showing the yields pre and post transgenes. And you can kind of see a little bit that there's a little bit of genetic and a little bit of, we're just protecting the yield there, right? So we're able to control weeds a lot more easily. As we think about the defoliators, Japanese beetles are the ones that I've got here, but at times we do have bean leaf beetles. We also have other critters insects that are sucking the sap out, right? And so one of those that comes to mind more toward northern Iowa is going to be the soybean aphids. And so again, if we are out there scouting, we can pay attention to the defoliation thresholds, the other insect thresholds, control them when we're needing to, and not just going out and proactively applying products. Here, just highlighting that there are some risks associated with this type of strategy for planting date, seeding rate, and row spacing, right? So we do have to pay attention to these things like white mold, downy mildew, frog eye leaf spot. How are those things going to get addressed in this sort of mentality? So how do we get free yield? And so again, it's just paying attention to what management practices are we using as we go out to plant, right? So if we're planting very timely, there's probably a little bit less concern. But if we get planting really early or really late, all of a sudden, then we have to rethink this, right? So we're going to get free yield by making sure that we get as much vegetative growth as we can. We have a quicker canopy closure, and we're trying to attain more nodes per plant. So the free yield math is that we can get, through optimizing these three things, we can get 2 to 3 extra nodes, 3 more pods, and we can get the 3 seeds per pod, or 3.3. That equates to about 5 bushels per acre. We factor in the commodity prices that we're at right now, and that's $60 to $70 per acre greater, just through optimizing, the building of this plant factory. So again, just to reiterate, we do have to pay attention to our risks. So there is some increased risk of disease pressure as we tighten down that canopy, whether it's SDS, white mold, soybean cyst nematodes. There are some seed treatment options available that we can look at, but they may not always be necessary either. If we have really good planting environments, really good environment for germination and emergence. And then the other risk of this mentality of thinking is what happens if we get frost damage or hail damage? And so by and large, if we have 50 to 70,000 plants per acre, we can still be okay. We can still do okay. We're still going to get full canopy closure. It just might be a week or two later. If we get 50,000 or less, then we might need to think about repairing the plant stand. So going back in and adding more seeds through a thickening up strategy, right? So if we have 50,000 plants out there, maybe we come back in and we add another 100,000 seeds, to try to get the biomass, get the canopy closure to be able to maintain that yield potential. So with that, again, just stressing, let's not forget the basics here of planting, row spacing, and seeding rates. As we get going into the growing season, make sure that you're able to adjust. So if planting does get delayed, what are some things that you can do as far as narrowing up row spacing, maybe adjusting that seeding rate? All very good things that we can be working toward and get a little bit of free yield out of the game here. So with that, thank you for your attention.